Hello and welcome to Switch, a project submitted by Wing Chan, Jeffrey, and Ved for CS410. What is Switch? Switch is a comprehensive job search engine which uses job postings and tweets from actual users of the Twitter. It allows job seekers to search relevant job postings submitted by actual Twitter users. In order to do so, we collect tweets related to job postings using Twitter's API and process them with natural language processing techniques to return relevant job results to our end users. In short, we help connect end users to actual hiring teams. The architectural view of Switch. Switch as an application is hosted on AWS. A cron job fetches the tweet service every 15 minutes that pulls and scrapes latest tweets from the Twitter API and stores them into the tweet table hosted in DynamoDB. Once the fetching is complete, it triggers a text retrieval process which uses NLP techniques, namely entity recognition and naive based classification, which analyzes tweets, discards irrelevant tweets, formats them, and makes data ready to feed into the Elasticsearch engine hosted on AWS. The Elasticsearch indexes and makes data search ready for our front end web portal. At the end, users visit our web portal to search actual job postings. Text processing and NLP techniques for Switch. As highlighted earlier, we extracted Twitter data to identify relevant job postings. We performed text mining steps to convert that text data into highly qualified and actionable item. For that, we used naive Bayes classifier to discard irrelevant tweets and identify tweets that pertain to a defined job category. For this project, our tweet extraction services queries Twitter for tweets containing keywords like developer and hiring. While most of the tweets in the query result pertain to job opportunities, many did not. For example, tweets such as, I saw you guys were interested in hiring a JS developer. Have you fulfilled that position? As we can see here, this particular tweet contains all the relevant bag of words, but they do not contain correct information, neither actionable relevant information, which defines the job category. For same, we implemented naive Bayes classifier. As an initial step, we collected an initial sample set of data and manually categorized each tweet as relevant or non-relevant to serve as our classification model. We relied heavily on Spacy, an NLP Python library, to remove stop words prior to model initialization and text classification. In addition, we also noticed best results when URLs, hashtags, and punctuations were removed from text prior to characterization. Our naive Bayes classifier can further be seen here in our GitLab, which has the code and the information of how we proceeded. We also used named entity recognition to extract key pieces of information of element to address the primary identifier in tweets, information relevant to end user, such as location, company, job category, and many more. Now the technological stack used in Switch. As highlighted earlier, Switch is hosted on AWS, so we ended up using a lot of AWS services. Some of them are being highlighted here, such as the Lambda functions, which have been heavily used to fetch tweets, process tweets, and perform any kind of text data analysis. These Lambda functions were created to address these tasks. To store the information and the fetch tweet, we use DynamoDB. Elasticsearch engine was used to index and make data ready for the web portal. S3 was used for storage of static resources. CloudWatch event, it was used to create scheduled cron jobs to pull and scrape tweets in every 15 minutes. We used Python libraries, namely Spacey, Tweepy, which is an easy to use library for accessing Twitter API, Pandas, Re for the regular expression operations, NumPy, JSON, and Request. Further information about our technological stack and documentation can be found here in our GitLab repository. Finally, let's move to the demo. You can access the web page of Switch by clicking on the link provided. As an initial load, it will show you all the job postings that have been scraped out of Twitter. These are actual tweets by actual users. For the ease of use, pagination has been created. You can load more jobs as needed. If you want to see the actual tweet behind this job posting, you can click on the keyword tweeted, which will take you to the actual tweet by the user. If you're interested directly into the job posting, you can click on the job posting, which will take you to the job posting site itself. If you want to filter based on location or based on other criteria, you could even do that. For example, if I want to identify all the jobs in California, I could filter that and it will list me out all the job postings in California. Similarly, job postings in Ottawa, like for an international location. Here we have all the job postings in Ottawa. Similarly, if I'm interested in job postings which are pertaining to a particular language, for example, like Python, I could search for job postings in Python. Similarly, for Java or SQL, we could have all those keywords on which we can filter the job postings. I can also look for job postings by specific companies. For example, job postings by Google. Here are all the tweets by actual users about the job postings by Google. Or in that case, even by, say, IBM. I could even be more specific about asking like Android developer, and I'll be able to find out the Android developers. And I can, in the similar fashion, go back to the tweet, go back to the job posting, and it'll show me the relevant job posting. With that, we complete our demo. Here, as a reference, are all the useful links and references that we used in creation of Switch. Thank you so much for your attention. Have a great day.